Hi everyone, and welcome back to Eve Math Tutoring. Today's lesson is on simplification of algebraic fractional radicals, also referred to as algebraic fractional roots. Alrighty. Now say you're given the following example, and you're asked to simplify something like this. Simplify the square root of 3a cubed over 5b. Square root. All right, so there's nothing I can do. Oh, wait a minute. Okay, now, first of all, this root is over the whole thing. So let me just rewrite that nicely. Okay. Now, this here can be rewritten as 3a cubed over 5b. Now, as you remember, when you've got roots, a over b, that's the same thing as root a over root b, okay? So in this case, you've got root 3a cubed over root 5b. So what you want to do is eliminate the root on the bottom, okay? So what I'm going to actually do here is I'm going to multiply this thing, top and bottom, by the root of 5b. Okay, and that's like multiplying this fraction by 1. I'm not actually changing the fraction. And when I do this, this here, root 5b times root 5b is the same thing as root 25b squared or 5b. So I eliminate the root on the bottom. Then I deal with whatever's on the top. So on the top I've got 15a cubed b. Now at that point, I've eliminated the root on the bottom, so check mark. So that's good for simplifying fractions with roots. And the thing I want to do now is look at the top, and I want to see if I can simplify this root up here. Now, there's nothing that goes into 15 that can be square rooted evenly, like the number, besides number 1. So like the number 4 square roots evenly, but that doesn't go into 15 evenly. The number 9, etc. So there's nothing I can do with this. However, this one right here can be simplified a little bit further. So root 15. This here can be written as a squared times a to the 1 times b, all over 5b. Okay? So, and the reason we did that is because we want to bring this out, and we can because there's a 2 here. And what happens is when you bring this out, this 2 divides that number and it becomes a. So I can bring that out, it becomes a. When I bring it out, it gets rooted. And then the 15ab stays inside of the root, and then I've got the 5b here. So this would be my simplified answer to that example right there. Okay? And for these, I've done previous lessons. You can take a look at my other lessons where I simplify algebraic radicals to understand how I'm simplifying this part here. Okay? Now let's do a few more examples. Let's do simplify 5ab over 6xy, and there should be a root here, and the question is simplify. Okay, 5ab over 6xy. So again, rewrite it as 5ab over the root of 6xy. Now I want to eliminate the root on the bottom, so an easy thing will just be to multiply by the same thing. And whenever I do the top of this, I'm going to multiply this bottom. I'm going to do the same thing to the top. So whatever I'm doing to the bottom of the fraction, I'm doing the same thing to the top. So this is not changing this. It's like multiplying this thing by 1. That's all I'm doing here, okay? However, the trick here is we're getting rid of that root. Because when you're simplifying algebraic radicals, you never want a root on the bottom of your fraction. So when simplifying, we do not want this. This is okay, but the root on the bottom is not cool when it comes to fractions. When I say not cool, I mean in mathematics, it doesn't go. Okay, so in mathematics, you never want the root on the bottom of your fraction, but you can have a root on the top of your fraction when you are simplifying fractions, and that rule always holds. It never ever changes. That's the great thing about math, is it never ever changes. It always stays the same. Alrighty, so following that rule, we're going to multiply this thing. So we're going to get 6xy on the bottom. Boom, I got rid of the root. Now the top. 5 times 6, 30, abxy. All right, let's see. Can I simplify this any further? So I'm taking square root. Now these all have an exponent of 1, so I'm not going to bring them out because then I'm going to get a to the 1/2, and I don't want a fraction on my variable. So when simplifying in algebra, simplifying algebraic roots, when you bring out the algebraic variable, you want the exponent to be a whole number, not a fraction or a decimal. So because these are 1s and there's a 2 here, 1 is less than 2, so that's going to end me up with a fraction or a decimal as my exponent for my variable, okay? So that's why I leave these alone. If this here had an exponent of 2, I would bring it out because that 2 would divide that 2 evenly and it would just become a when I bring it out of the root. In this case, if I bring this out, it becomes a to the 1/2. Okay, so the 30, so that's that part. Now the 30, you want to think of, is there a number that goes evenly, that goes into 30 evenly, that can be square rooted perfectly? So like the number, besides number 1. So the numbers that can be square rooted perfectly are numbers like 4 or 9 or 16, because when you root these guys, you get a whole number. Okay, that's what I'm looking for. But you know what? None of these perfect square root numbers go into 30, so that means that stays in there as well. So this means that I am finished. Now you could also mention that x and y do not equal 0, and the reason you would do that is because when you have fractions, the denominator cannot equal to 0. If it does, that means that your number or your fraction does not exist. Okay, so you cannot have a 0 on the bottom. Alrighty, so that's how you would do that example. And these examples are taking me back. I feel like I've gone back 10 years or 15 years back to when I was first doing these in high school and then teaching students, and you know, haven't seen it for a long time, but you know what? When I do the examples on here on my channel, it just refreshes it right away. It comes right back to me, okay? But again, like I said, the thing is with mathematics, the base rules are so important, because if you don't understand these base rules, the stuff that follows is just going to become more and more difficult. So you have to have a solid understanding of the base rules of algebra. That's the key to understanding mathematics. Okay? So let's do a few more examples. Alrighty. Let us do, how about this one? Simplify the third root of 1 over x squared. Very nice. Okay, I would rewrite that as the third root of 1 over the third root of x squared. And then what I'm going to do is I'm going to multiply the bottom by the same thing. Nice and easy. Wait a minute. Not by the same thing. I'm taking that back, because what I want is what I want here, I want to try to get rid of the root on the bottom. Now, this is a 2. If this was x to the 3, that would work perfectly, because when I take it out of the root, it would just become x, and the root would just disappear. So what I'm going to do is multiply this by x to the 1, the cube root. These roots have to have the same number when you're multiplying here, okay? When you're simplifying something like this. So you're going to have the same thing here, and this is going to be a 1, and so I'm going to do the same thing at the top, okay? I don't have to write the 1, it's the same. Now, the reason I did that is because when I do multiply these guys, I get the cube root of x to the 2 times x to the 1, which is x to the 3, and on the top I get the cube root of x. And on the bottom, what I see is when I take this out, when you with algebra, when you take it out of the root, you divide your exponent of your algebraic variable by the number here. And 3 divided by 3 is 1, so I just get x when I take this out of the root. And then the cube root, there's nothing left, so it just disappears. And the top becomes root 3x. That remains the same. So that is my final answer. Okay? And what happens to the top is there's a 1 here, and that's why I didn't bring it out, because it's less than 3. Okay? Because then I would have gone x to the 1/3. We don't want that, so we leave it as is. Now, you also can mention that x does not equal to 0 because we cannot have the denominator of a fraction equaling to 0. Okay, so this is how you would tackle this type of question, okay? This is involving cube roots. Now, I'm going to do a few more of these. I'm going to do one that's a little bit more complicated. So I'm going to do the cube root, simplify the cube root of 81x to the 4 over 16yz squared. Okay, so I want the cube root of this thing. So first thing, rewrite it like this, 81x to the 4 over cube root of 16yz to the 2. All right, next step. What do I have to multiply this thing by? Well, let's see. I'm going to multiply it by, first of all, the cube roots have to be the same. So let's start off with that. So whatever I figure out I'm going to multiply the bottom by, that's what I'll multiply the top by. So we tackle the bottom first because what we want to do is eliminate the root on the bottom. So on the bottom, we've got 16yz squared. Now, okay, now let me just see here. This one is really interesting. Oh my God. Okay, just thinking here. Okay, let's see. What should we do here? Okay, 3x. Let's see. 16yz squared. The answer. Wow. Okay. Okay. Let's see here. Did I copy this wrong? Okay, all right, I'm going to tackle this thing here. Okay, so what do I want? I want no roots on the bottom. What I want to multiply to eliminate this, all right, here. So I'm going to have to multiply the y to the 1 by y to the 2. That's going to get rid of that. That will become y to the 3, which will come out of the cube root perfectly. I'm going to multiply z squared by z to the 1. And the reason for that is when I multiply those two, that's going to move out perfectly. The 16 cube root, 4 times 4 times 4. Let's multiply it by 4. If we do that, then we can take the cube root of 16 times 4, which is 16, 24, 24, 50. 3 times 6 is 12 and 18. 3 times 3, 48. No, that's not what I wanted. I want 16 times 4. 4 times 6 is 24. 4 times 1 is 4 plus 2 is 64. Yeah, okay. So the cube root of 64 would give me 4. 4 times 4 times 4. Yeah, alrighty. So I figured it out. Okay, so 4y squared z. Alright, now let's do our answer. So when we multiply this, what happens is we get the cube root of 16 times 4, which is 64. Y to the 1 times y to the 2 is y to the 3. Z to the 2 times z to the 1 is z to the 3. Boom. top part. Top part becomes 81 times 4, which is, I have no idea. Let's see what it is. 81 times 4. 4 times 1 is 4. 4 times 8 is 32. Boom. 324. Nice. 324. X to the 4. Y to the 2. Z. Okay. Looking good. Okay. Now, what we're going to do now is work with the denominator. So, okay, that's a little bit. Okay, bottom part. The cube root of 64. So 4 times 4 is 16, times another 4 is 64. So if I take the cube root of 64, I get 4. That comes out of the root, nice and easy. Y to the cube cubed is just equal to y. It's 3 divided by 3, it becomes y to the 1, and it comes out of the root, nice and easy. Next one, z to the 3. 3 divided by 3 is z to the 1. Boom, finished. Okay, so there's nothing left. So now I just eliminated the root on the bottom. Okay, now the top part of this question. Now for the top part, the cube root of 324, well, let's see, 3 times 3 is 9, times 3, is equal to 27, 27 times 12, 2 times 7 is 14, 2 times 2 is 4, plus 1 is 5, 1 times 7, 2, boom, add these, 4, 12, boom, 324. Okay, so what I'm going to do is I'm going to write the top part as, I'm dealing with the number first, 324. I'm going to write 324 as 27 times 12. The reason I'm doing that is because 27 can be cube rooted perfectly. Okay, I'm going to keep these guys. Oh, no, I'm not. Now let's deal with the top part. X to the 4 is going to be rewritten as x to the 3 times x to the 1. Okay, and the reason for that is because I want to take this part out. And the 4 divided by 3 is going to give me a decimal or a fraction. Doesn't divide evenly. However, 3 divided by 3 works. And I can just rewrite x to the 4 as x to the 3 times x to the 1. Y to the 2, z. Okay, let's do the next example. So, sorry, let's do the rest of this question. So when you take the third root of 27, that's going to give you 3. So that part's out. When you take x to the 3, the third root of x to the 3, you just get x to the 1. X to the 3 divided by 3. The other x stays in, so does that 12. So let's keep those inside the root. And don't forget your little cube root here. Okay? Okay, sorry, let me just rewrite this nicely here. Okay. That's not x to the 3, that's 3x times cube root of x. So I've got to do this nicely. So I've got to do 3x times the cube root of 12 to the x. Okay, now x to the 1. Y to the 2, I can't do anything because it's less than 3, so it stays inside the root, and z stays inside the root also. This becomes, the bottom's just 4yz, so I've already dealt with the bottom because I've gotten rid of the root. There is my final answer, ladies and gentlemen. I hope you guys appreciate this because I'm telling you, this right here is real mathematics, okay? This is why I went ahead and did my master's, because I love math, okay? So did an undergraduate degree at U of T, Mississauga, and then went ahead and did my master's at York University in applied mathematics. And at that point I decided, okay, that's enough. And at that point did a 1-year Bachelor of Education degree at York University. And the reason is because I love math. So I just kept on studying, okay? So I hope you appreciate this. because this here is true mathematics, and I hope you understand it. It is tricky, but with a lot of practice, you can understand this stuff, okay? Now, once you take this out, the third root of 27, like I said, is 3. 12, I can't do anything with that. There's no number that goes into, like, this is simplest form, because the number, let's see, 2 times 2 times, 8 divides cube roots evenly, but that doesn't go evenly into 12. X to the 3, we pull it out, we get x to the 1, so there's actually a 1 here. The other part of that x to the 4, though, stays inside the root, the x to the 1. Y to the 2, can't do anything with that because it's less than 3. So 2, if I took it out, it would be y to the 2 over 3, which would not work nicely. If I took out z to the 1, it would be z to the 1 over 3, which does not divide out nicely, okay? And then the bottom we already dealt with. We've gotten rid of the cube root. And you can mention that y and z do not equal 0. Oh, geez. Okay, I'm going to do one more example. This one right here is a great example. If you can do this example, it means you really understand how to simplify fractional roots involving algebra. Okay? So let's do one more example. I'm going to do one more. I'm going to do how to simplify the 6th root of 4x to the 6 over 9. Okay. Again, rewrite it as the 6th root of 4x to the 6 over the 6th root of 9. Now, what I want to do is multiply the bottom. This one's a little bit easier because there's no algebra on the bottom, just a number, okay? So you want to multiply the bottom by something that can be 6th rooted evenly. Okay, so I'm just thinking now, what would that be? Let's see. Let's start off with 2 to the power of 6. And then go to 3 to the power of 6, and then we can see if we can get this number to be something like that, okay? So I need my calculator, which I don't have at the moment, so that's not good. 2 times 2 times 2 times 2 times 2 times 2 times 2 is equal to what? So 4 times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Boom, okay. 3 to the power of 6 is 3 times 3 times 3, 3, 3, 3. Again, a scientific calculator would save you a lot of time right now. 3 times 3 is 9, times 3 is 27, times 3, 27 times 3 is 81, I think. 81 times 3 is, I have no idea. 3 times 81 times 3, 3 times 8 is 24. 243. Okay, 243 times 3 is 3 times 2 is 9. 3 times 4 is 12. 3 times 2 is 6 plus 7 is 729. Holy macaroni. And a calculator, scientific calculator would have taken you from here to here in one step. Okay? What I want to do, and you know what? 9 does go into 729. It doesn't go evenly into 64, but I'm sure it goes evenly into 729. Okay? So what I'm going to do is I'm going to try to get the bottom to be the 6th root of 729. That's what I'm trying to do here, because I'm trying to get rid of that root. So I'm figuring out, what do I have to multiply root 6 by? Sorry, the 6th root of 9 by. So what do I have to multiply 9 by to get it to be 729? Okay? So the answer is... what in the world is going on over here? Okay, this is going to be more difficult than I thought. Just thinking here. 9 times 9. Yes, it does work. No, it doesn't. Damn it. 7, yes, it does. No. Hold on, wait. 9 times 9. 9 times 9 is 81 times 9. 81 times 9 is 729. So what I could do is I could multiply this by the 6th root of 81. Okay, let's see if that works. So when I do that, I get the 6th root of 729. Okay, now let's switch to blue here. Okay, now the top part's going to become 4 times 81, which is, geez, it's a really big number. And then x to the 6. Oh boy, this is getting really messy. Okay, 81 times 4. Okay, let's leave the top for now. Let me deal with the bottom here. So the bottom is the root 6 root 729, which is equal to 3. So that part works. Okay, the top part becomes, let's do it in red, or purple. 81 times 4. 4 times 1 is 4. 4 times 8 is 32. 324. Okay, the top just became 324. Okay, okay. Equals, let's go from here to here. Now, the bottom, the 6 root of 729 is 3. God, I should have brought my scientific calculator. That would have saved me a lot of time. Okay, the 6th root of 729 is equal to 3, okay? Because 3 multiplied by itself 6 times is equal to 729. So I just eliminated the root on the bottom, which is great. That's what I want to do. Okay, however, what I need to do is deal with the top part now. So first of all, x to the 6 divided by 6, great. The 6th root of x to the 6 is just x, so I can pull that out too. So I pulled that out. Now I got to look at this number. So 324, well, what goes into 324 that can be 6th rooted? Not, let's see, maybe, well, 6th rooted. Okay, well, 60. If we can express 324 in terms of 64, then we can pull some numbers out from there. Okay, so 64. So 64. Let's just see here. Let's try 64. Let me do that in purple or in red. How about red? 64 times 324. 5 maybe? No. By 6. 6 times 4 is 24. 6 times 6 is 36. That's too big. No, that's not going to work. Okay, let's do 64 times 3. That's my gut feeling. Let's go with that. Let's do 3. 64 times 3. 3 times 4 is 12. 3 times 6 is, okay, put the 1 here. 3 times 6 is 18 plus 1, 192. Jeez. Okay, what's 192 plus 192? No, that's not going to work evenly. 18. No, that's too high. Okay. Well, it does go in 3 times. No, it doesn't. Wait a minute. 192. No, that doesn't work. Okay. What about 64? You know, I don't know what I can do with that 324 on top. Okay. Guys, give me a minute. I'm going to go grab a calculator. Okay? Save you a lot of time here. Okay, I just grabbed a scientific calculator, which is going to make this question a lot easier, okay? So first of all, 3 to the power of 6 is equal to 729, so that part's good. Now what we're trying to do is figure out if there's a number that goes into 324. I'm just going to erase this. Oops. Whoopsie, whoopsie. Let's erase this. Okay. I'm going to clean this up a little bit here because it's a little bit getting out of control here with my no calculators. That's why a calculator is so important when you're doing this kind of stuff, okay? Okay, we'll keep this stuff at the top. That's okay. Okay, so let's see here. Now, so what I want to do is think about, now I've dealt with this and I've dealt with this. Now I want to deal with the 6th root of 324. So I want to see if there's a number that can be 6th rooted that goes into 324. So 64, I'm going to do 324 divided by 64, and it does not work evenly. Okay, so that part does not work evenly. Let's see here. 18. That doesn't work. You know what? The answer is the 6th root of 324. Okay, let me just put that back in blue. There's your answer. Okay, so I can't come up with a different solution here. This has just gotten out of control here. Yeah, so I would leave the answer like that. Okay, that would be your final answer. So that one was quite fun. So the 6th root, like I said, divide it up here. Try to eliminate the one on the bottom. So 9 times 81 is 729. And you can take the 6th root of 729. 729 to the power of 6 is 3. So that part works out nice. And then the top part is just out of whack here. X to the 6 divided by 6 becomes x to the 1. So you can pull that out. But the 6th root of 324, you cannot get rid of. So there is your final answer for that one. Okay? So lesson of today is always have your scientific calculator with you when you're doing your math homework. Okay, hope you enjoyed. Remember, any questions, post them on the channel page. Don't forget to subscribe. I'm going to have a lot more lessons. I'm going to be giving out my math knowledge to the world, to all of you, to hopefully help you along with your math struggles. All right, guys, don't forget to subscribe.